Hello everyone, and welcome to this latest PV Tech TechTalk webinar. This is Mark Osborne, the Senior News Editor at PV Tech, and I'll be the moderator for today's webinar. We're pleased to partner with Trina Solar, Sungrow, and DNV GL for this 1 hour Tech Talk. This will cover LCOE reduction goals with Trina's large area Vertex modules that were launched earlier this year. Our presenters today are Kevin Xu, Vice Director of Tracker Product Management at Trina Solar, followed by Fred Zhu, Systems Solutions Manager at Sungrow, and we'll finish with a presentation from Minhua Leung, Senior Engineer for Solar Technology at DNV GL. Lots of good technical data to get through today in this 45-minute Tech Talk, please ask any questions you may have throughout the presentations, and we'll hopefully get to some of these at the end. So if Kevin is ready, I will hand over and we can get started with the first presentation. Kevin, the floor is yours.
Okay, thanks Mark for your introduction. So hi everyone, this is Kevin from Trina Solar. So today my topic is our new Trina tracker to match with our Trina's Vertex module. Okay, I think in the last year, from the PV module industry side, it's a very big year for the power bin point of view. So from this chart, you can see in last year, the whole main industry module power bin have increased, I think, from 400 watts to over 500 watts module. So totally 100 increased from the power bin. That equals to, in the last 10 years, the totally module power bin in the last 10 years. So that's the reason why I say last year it's a very big change year from the module side. So this is my background, because when the modules power bin increased a lot in 1 year, that also means their technology and also including like the weight, size, these features have changed, and all these changed features will also improve the like our upstream and downstream industry changes. So today's I will introduce from the tracker side how the trackers match with a big module change. But I think not only the tracker and the inverter and the BOS, the LCOE calculation will be all influenced. So in today's webinar, I think from our tracker to inverter and to the BOS calculation, we will all focus on the same target to reduce the LCOE, the electricity cost. Okay, so that's today's topic background. Okay, so this page is to show, as you know, Trina is doing the module and the trackers product together. So the upside is Trina's Vertex module, the loader map. So we start from the 400 watts module, and at the early of this year we have go up to 500 watts module, and now we are at the 550, and we believe next year the whole industry, including Trina, we will go to the 600 watts module. So that's very easy to tell from the module's power bin increase a lot, but behind the module power bin increase, so you can see the size, their weight also is actually is increasing. So that's where have the influence to the trackers design. So you can see here when the module size increased, it will influence the picture shown here, where includes influence the track length and the column span, and also the panel length increased, and also will influence all the trackers structure design. So as I said, Trina is doing the module and the tracker together. So it's a good thing that when we decide to develop the new modules at the same time, we are doing the trackers new design to match with the new modules trend. So it's a totally packaged solution, and we design and evaluate the packaging solution in one page, in one picture. So I think for Trina's module and the track solution is a totally compatible solution, and we test it together. So that's our research from the module side to track side, the background. Okay, so let's go to for Trina's Vertex module. What product line from the tracker side we have? Basically, to match with the Vertex module, take 550 watts module, for example. Now we have a main product line, which called a Vanguard and Anjai. And also we have put our modules power bin, also like added to the product name. That's Vanguard 550 and Anjai 550 to put the tracker and module together, even from the product name. And the Vanguard Vanguard from the technology is independent load, and Anjai is dual link load. So they are adapted to different installation application. So as their name, Vanguard is more like like a piano, like a piano. So it's suitable for the complex installation applications, like the uneven ground-mounted conditions. And Aja is like robust and easy install application. So is more suitable for even ground-mounted applications. So different product line and different application. And also for the modules layout in the Vanguard product, we have a 1P and 2P 2P option for different applications. So that's the main product line and the product configuration to match with Vertex module and the two different applications. Okay, so I think this page, next is to when our module side have very big change, and also we have trackers new product. What have changed mainly? So from this, first from the parameters, we can have a comparison. Just take Trina's Vanguard 550 2P product, for example, to explain the update. So from the parameters comparison, you can see here, first is the low size. We have become bigger. So before is 90 pieces per load, and now is 120. Okay, and also the trackers of length. Before is 45 meters, and now is nearly 70 meters. Okay, and also we have increased our trackers widths. That's nearly 5 meters. So and all these the trackers become like the module become longer and bigger. To adapt to the new bigger module trend. Okay, so next is just now is parameters. So from the picture you can have a more direct image. So what we have many changes. So here basically we have enforced because module is bigger and heavier. We have update our pipes design from the size and also the shape. And the second is we have make our bearing as a new design and to can bear heavy loads. And also the third is like the torque tube also become bigger and stronger. And also plane we have make it longer. And also most importantly is for the driver system, we have changed from the single driver system to the multi-driver system. Later I will explain in more detail. And also we have in-house our controller box from the power and also his smart tracking function. So in the following my presentation, I will explain more in detail in this, which is branded in yellow. Okay, so because this is our key technologies we want to introduce in more detail. So this in green, so it's just to update the size, okay, to make it stronger. Okay, so first is I just now I mentioned, so for the multi-driver system. So look the picture here. So I think before the whole industry for the module looks the modules layout. We have a one single driver system here, and the torque distribution is like here. Okay, but now we have a three driver system. From the video you can see here from one drive system to let me repeat again. Okay, so this is one drive system, and from the transmission we'll go to another drive system. So this drive system will go to another, so totally we'll have three, but before we only have one. So for this multi-drive system we have many three advantage. First is stability and accuracy. So stability, because before we only have one drive system, but now we have three. The force and the torque distribution is more balanced than before. Okay, so and also because now you have three control system here. So when you control the whole system, it is much easier to control the accuracy of the driving system. So so first is stability, and the accuracy is much better than before. And the second is for the safety. So for the driving system, one function is to driving the tracker. And the second is to when, like for example, when the wind comes, you need to lock the drive system. So the drive system is like a lock to keep some system safe. So it's very easy to understand. Before you only have one lock to control the system, but now you have three. So it's from the safety point of view, it's much safer than before. And the third is, I think, for the new drive system and all the new structure design, we all do the new wind tunnel test to assure the reliability. So it's not only design update, it's also the test update confirmed with our RWDI, our wind tunnel test partner in Canada. Okay. So this is most important updating for from the multi-driver system point of view. Okay, this is point one, and the second is so for our bearing system. So Trina's bearing system is quite special compared to any others bearing system in the market. So here we showed the conventional bearing system. Conventional bearing system is like the picture here. So it's fixed. It's not, I cannot adjust. But Trina design like the video show here. It's a spherical system, so it can be rotate every direction. Okay, so what's its benefits? So take the conventional bearing system here. If your torque tube, and during your installation, you always have the tolerance from the installation and the thinking from the long time operation life cycle time. So when because this bearing is unadjustable, so it will cause mechanical stress when the tolerance and deformation happens. But with Trina's spherical and rotatable bearing, you can see here our torque tube in this bearing. It can be very easy to adjust and to release the stress during the installation and the operation life cycle. So look at the picture on the right side. You always face the uneven ground and deformation from the land, and also you have installation tolerance during your installation. So if the torque tube can release the bearing can release the stress for the torque tube, it will help the system much reliable to ensure the stability for the whole system. Okay, and sorry, one thing I still have to stress here. This spherical design is totally patent and protected by the patent. Okay. And the third is for our control box. So for the control box, which we call the super tracker. So as you all know, Trina is doing modules and tracker together. So we totally understand for the tracker, we need to consider the modules trend into together. So one important trend for the module side is not only the big size and also the bifacial. So from the bifacial point of view, when we design the control box, so we have developed the smart tracking calculation. So to achieve the highest power gain for bifacial modules, especially in the low latency, diffuse latency condition. Second is for the smart backtracking technology. So it's from the video you can see here. When there is shading because of the uneven ground, so the whole system, according to this smart tracking technology, they will adjust their tracking angle to avoid the shading automatically and achieve the maximum power output. So this is we have applied this patent, and also for smart tracking, we are working with the independent third party to prove the power gain for the super trackers gain, which called CGC. Okay. And this is the data from our independent third party, and we have monitored half an year. So from the comparison, you can see this number 14 is our baseline without super tracker, and number 8 and number 13 is with the super tracker. So from the data you can see the maximum energy gain can reach to above 5%, and on average it will around 3%. And also we do the analysis from the morning to the sunset. Okay, so you can see here the bars is a comparison from the power output, and the curve represents the gain percentage. As you can see here, all the most gain percentage come from in the morning and the sunset, because at this time low latency is take more percentage from the sun. So at this condition, the super tracker is working very closely with the whole tracking system. So in this condition, to achieve its highest again in the morning and in the sunset when the low latency percentage is very high. So this is totally proved by our independent third party CGC this data. Okay. So let's whole thing from the multi-drive system to our bearing patent design, and the third is our super tracker function. So this is our main technologies for the whole trackers systems. Besides the mechanical structure update. Okay, at last, I'd like to summarize as Trina Tracker our main value for our customer. First, I think we focus on the reliability from the design to the structure and also the bearing. Just now I have introduced. And secondly is for the more energy yield. Just now I have introduced the bifacial tracking technology and the super tracker technology, and all these things is to help our customer module to tracker together to lower our LCOE. Okay, so that's our Trina Trackers core value for the whole things. So totally until now, last now is for Trina Tracker. Now we have totally. We have a 5 gigawatt globally shipment and installation so far, and based on different region and country and different application. So that's all for tracker side. Okay, so I think I will leave the following time to our partners. Fred from the Sungrow to introduce our how our inverter to adapt to the high power beam module. So, Fred, I will left my time to you. Thanks.
Okay, thank you, Kevin. I'm very happy to have this opportunity to work with Trina Solar. Hi, everybody. I'm Fred from Sungrow. I take charge of PV and ESS technical support for Sungrow Middle East and Africa market. Today, I would like to talk about how PV inverter to match high power PV modules. I'm sure you are interested in this topic because the major PV module manufacturers had launched the new era of 500 watt peak plus PV modules a few months ago. It's not news anymore that launching the new PV modules. In the past 5 years, the module power kept increasing every year, and it was proved to be the most efficient way to reduce system cost. From this table, we can find that from 345 watt peak module to 455 watt peak module, the system cost was cut down dramatically in terms of lower cable cost and lower mounting system cost. I do believe that the new era of 500 watt peak modules would bring further cost reduction, but at the same time, it will also bring some challenge to the balance of system, such as the mounting system, DC cable design, string design, and PV inverter design. For the new era of 500 watt peak modules, now there are two main technology roadmap by using different PV cells. One technology used 210 millimeter PV cell, which is featured with high current and low voltage. The other one used 182 millimeter PV cells, which is featured with high voltage and low current. We can easily understand these two roadmap by the formula power equals voltage product current. Trina Vertex series module is a representative product of high current roadmap. If you see the table on the right side, you can find 535 watt peak and 545 watt peak module. They are with very similar power, but the current increased 20%. On the left side, we made a brief summary. If you choose higher current module, you will have longer string but less strings. This will lead to lower cable cost and mounting system cost. On the other hand, the cable loss and mismatch loss will be increased also. But if you choose higher voltage module, you will have shorter string and more strings. The cables and mounting cost will be increased. But if we enhance the system voltage to 2000 volts, the higher voltage module would be more competitive. But for current 1500 volt system, higher current module from Trina would be more competitive. For the higher voltage module, because the MPPT current never beyond 15 ampere, Sungrow current product, I mean both central and string inverters can match it well. But for higher current module, like the Vertex module, because the MPPT current is higher than 15 ampere, Sungrow central solution is still okay, because the PV strings are connected by is collected by combiner box. We only need to upgrade the fuse of each string from 22 ampere to 30 ampere. And our central solution supports very flexible DC side design to get lower DC cost and higher DC ratio. But Sungrow current strings inverter can maximally handle 15 ampere strings. But our next generation string inverter we will upgrade to 20 ampere for each string. And this new string inverter, it means it can match the new Vertex module from Trina. And this new module will be launched by the third quarter of 2021. It means next year. For Sungrow string inverter, we need to update both hardware and software to adapt to the new era of PV module. From the circuit diagram of Sungrow string inverter, firstly, we need to upgrade maximum input current and expand the detection range of current. Secondly, IGBT chip also need to be upgraded. At the same time, we need to recalculate the heat dispatch and cooling system. Thirdly, we need to verify the overall algorithm and reliable of PV inverter. And it means the test and the certification shall be updated also. When all the BOS equipment are ready, we need to decide which roadmap to follow. If you see the two graph on the right side, we can easily understand why 500 watt peak plus PV modules benefit total PV system after detailed calculation. And we can never say which technology roadmap is better than the other one without a specified project requirement. Because there are too many factors which will influence LCOE. In other words, both PV module, both technology have their advantage. For example, if CAPEX is the most important factor for you, you can benefit from high current module, mainly because of the lower cable cost and the lower mounting system cost. But if performance ratio is more important for you, then high voltage module would bring a lower cable loss and mismatch loss for you. So my calculation is based on the table on bottom left. In this table, you can find we choose two typical PV modules which apply different technology roadmap From this page, we can draw the conclusion that before we choose PV module, we need to do overall consideration in terms of CAPEX, energy yield, and other factors. Okay, in the next few pages, I will introduce the innovation trends of PV inverters. As we know, PV inverter is one of the most important devices of PV system because it influences the system cost and grid connection a lot. Definitely, Sungrow is PV inverter manufacturer, but we always consider how to improve the whole system as our innovation direction. I think this is the reason why we always stand in a leading edge in the industry. You must be very clear about how PV inverter influence LCOE of a project. We know a suitable inverter model can bring lower CAPEX, lower OPEX, and higher energy yield. But today, I would like to highlight AC side of inverter. That is a great support and reliable connection. If you see the graph on the right, with more and more renewable energy connect to the grid, the renewable energy become the body part of the grid. Therefore, PV inverter must provide robust support and a fast response to the grid. And how to combine PV and ESS together is also a trend of innovation for PV inverters. Sungrow Central solution, which is a containerized turnkey solution, it contributes a lower LCOE for DC side. And the smart communication unit inside the inverter can collect all data from PV field, include the tracker. It makes the O&M more efficient. Also, the PV inverter is bi-direction converter, which can accept DC coupled ESS in the future. From this year, more and more project bidding requests PV inverter to have ESS interface. For AC side, a Sungrow inverter can provide fast response and adapt very quick or very weak grid. These reasons makes us more competitive in the project bidding. Here, I want to introduce one of Sungrow patent technologies here. We call self-constructed grid function. It means the PV inverter can do hot commission without grid. The power is from DC side. This function can shorten construction period at most. For the project, which located in complex terrain or very remote areas, Sungrow would suggest to use string inverter solution. This inverter module SG250HX is very competitive product in the market. We just won Qatar 800 megawatt project by using this inverter model. Sungrow patent PID recovery function is also very. I want to introduce to our client. This is very standard integrated in the inverter, and this function can bring more energy yield and can save AC cable cost if you choose TN grounding system. But other string inverter manufacturer doesn't have PID recovery function, and they cannot support TN grounding system. And Sungrow string inverter together with Sungrow monitoring platform can provide online IV curve scanning and diagnosis report for free. Compared to manual test, very traditional way, Sungrow smart IV curve scanning function can save OPEX for more than 20%. And we can provide preventative O&M suggestion, and this can improve the plant performance for the continuous and stable operation. It means IV function can lead to a higher energy yield. We did some tests in some real plant. For 100 megawatt utility plant, we can finish the scanning and provide analysis report for the whole plant within 10 minutes. Okay, Sungrow became the global leading PV inverter supplier since 2015, and we became the one of the top two inverter supplier in the market in the recent 5 years. And by the end of October of this year, we already shipped 24 gigawatts to the market. And we believe that by the end of this year, we can totally ship more than 30 gigawatt PV inverters to the global market. Thank you. I will hand it over to Ms. Minhua from DNV GL.
Thank you, Fred. My name is Minhua Liang. I am part of the solar technology due diligence team here at DNV GL. And today I'm going to talk to you about an analysis we performed for the Trina Vertex modules. Our previous speakers have already introduced the idea that we have entered the age of the 500 plus watt modules. Now, what does this actually mean in the field, and how do these larger modules affect our design parameters? We wanted to see what these differences are when we put these modules actually in a system, and then compare the performance and cost side by side. In order to get this baseline for comparison, we set up the same system sizes for 3 module types. The first module here is the 450 watt module. This is very similar to the modules that we see in the market today. The next one is the 535 watt module. This is very similar to the general design of the previous module. And the only differences really are the larger dimensions. And then finally, we have the 545 watt modules. Now, these are the Vertex modules that Trina is rolling out, and they have a fundamentally different design than the other 2 cases. They have a low voltage and a higher current. And this means that in terms of the design, in order to create the same number of, in order to create the 1500 volt typical system, each module has a lower voltage, and so you can put more modules per string. So here we have 35 modules per string. And then, as expected, when you have a higher module rating, the number of modules also decreases in order to keep the same system size. Next, we come to the inverter, and there's no surprises here. This is the same for all cases in order to keep the same system size. And then the tracker. We chose Nextracker here, not for any complicated reason. We simply chose it for example purposes. We've done many projects with these trackers and have a certain amount of data on them. Now, if we just take the typical Nextracker, any type of tracker can only support a certain amount of weight. And with these larger modules and the higher number of modules per string, it can't support as many. And so this tracker can only support 70 of these larger modules. And there's only 2 strings. And this also affects the tracker length. So you'll have shorter trackers, but you'll have more of them in order to keep the same DC and AC system size. And the last thing I wanted to mention here is the ground cover ratio. Here we keep the same ground cover ratio across the 3 cases so that the shading and the bifacial impacts are roughly the same across the comparison. And now I wanted to talk a little bit more about how these Vertex modules impact the overall system design. So we talked a little bit about the inverters, and currently our inverters have a string input that's typically 15 amps. And you can see here that these Vertex modules have a much higher current, almost 40% higher current. And so the future inverters need to design for these higher currents in order to be compatible with these modules. And then moving over to the overall wire length in the system, when you put all of these different electrical components together, how does that affect the overall system? First, the DC, because each string has more modules, the actual home run wiring, the DC home run wiring is shorter. And in order to compensate to get to the point of interconnection, you need longer AC wiring. So overall, shorter DC, longer AC. And then we come to the energy model. As we all know, energy is a key part of the LCOE calculation. So for the energy model, we took two locations, one in Spain and one in the US. This is to take a typical example from the European and North American markets. The weather is pretty similar in both of these cases. You can see the GHI is pretty similar, and these are rather sunny places. So we ran through these numbers, these two locations through PVSys. And as you can see, there's some slight variations in the DC and AC ohmic losses. But when you run all of these numbers into PVSys, the end result really is that there's not much of a difference between the 535 and the 545 watt modules. The energy yield factors are pretty similar between these 500 plus watt modules. So finally, we come to the LCOE comparison. The LCOE, as we know, depends on both cost and energy. And as I just mentioned, the energy wasn't very different between the 535 and 545 watt modules. And so it really just comes down to the cost. The cost here was driven mostly by the differences in the EPC cost. All the other costs, of the development fees and the OPEX, is pretty similar because the system size is similar for, or the same for all of these cases. So what drives the lower EPC cost? First is there's fewer number of 545 watt modules. And so for the same power, for the same module price, you get a higher power rating. So there's some cost savings there. And then overall, the calculations, the way that the math worked out, the 545 watt module also had less tracker material. And then finally, the amount of DC wiring was lower. And so since the overall cost of DC cables is lower than AC cables, or the cost of DC cables DC cabling is generally more expensive than AC wiring. And so when there's less of DC wiring, there's some cost savings there as well. And so what do all of these numbers mean to the actual LCOE? So the overall cost of the 545 watt modules was lower than 535. And we mentioned at the top that the next tracker wasn't able to support as many modules and as many strings as the other cases. And so this LCOE could be even lower once those trackers are optimized to fit more modules per string. And that is the case with the Trina tracker. That's the point that Trina tracker is trying to solve. And and then another thing just to keep in mind here is that the inverters, this calculation assumes that the inverters will be able to handle that increase, that much higher increase in current. But really that product is not available yet. And so that is a future improvement that will have to happen. But overall, once the trackers are optimized, the LCOE costs can be even lower for the 545 Vertex modules. So that brings me to the end of my presentation, and I'll pass it over back to Mark.
Well, thank you, Minhwa, Kevin, and Fred for your presentations today. Really, really good. We're now ready for the Q&A, and let's try and squeeze in as many as possible in the short time that we have left. So perhaps we can start with a question for Kevin. So Kevin, if you'd like to unmute. I think this is a question that has come up quite a lot during the presentation. Your Trina's covering some new trackers, the Vanguard and the Agile, but could you explain, what's the difference here, or what's going on regards what people understand as like the Trina Pro and the recently launched, Trina Pro Mega? Perhaps you can just give us a little bit more insight into this side of what's going on with Trina Solar.
Okay, I think first, thanks for this question, and I think really it's a very good question. I can use this question to explain in this year for Trina Solar from the tracker business for different name and how our business goes on. So I think first, I think last year we have the Trina Pro. For combined with the module and the tracker together, it's Trina's first tap into the tracker business. And for this year, combined with Trina's new Vertex module, we have the Trina Mega. Just like the name, Mega is big. So for the Mega, it means we combine with our Vertex module and our new generation's tracker compatible with the Vertex module. And for Trina tracker is, I think for last 2 months, Trina have just finished 100% of acquisition for Enclave. So now Trina's business model becomes more flexible. So we're not only selling the package solution module, inverter, and tracker together. We can also sell tracker separately to our customer. So now we are more flexible and more options to our customer. So that's different names, but different options and different product combinations to our customer. Yeah. Thanks for this question. Yeah.
Okay, Kevin, thank you for that. Just staying with you for a moment, excuse me, and related to trackers, obviously there's a very topical very topical question here about wind dynamics. Is there, and question here is kind of combining two questions, I guess. Is there a recommended stowing locking position, for high wind conditions with these new trackers, and what's the ultimate wind pressure that the tracker can withstand, from a wind pressure value point of view? Perhaps you can just explain, give us an update on that.
Yeah, I think this question is a very how to say. It really depends. Depends on the different tracker structure, different trackers load map. So I don't think there is a universal answer to say there is a standardized angle for the wind protection stow angle. I think just for Trina's trackers, for example, before we also prefer with a very big angle to the stow to the wind protection. But when we introduce our Vertex module, just like I introduced just now, we have changed it to our multi-driver system. So in the multi-driver system, so we have a very confidence to keep the system stable during the vibration under the big wind. So in this case, due to the multi-driver system, we have changed our wind protection angle from the like previous 60 angles to the 0 angles. But that's due to the multi-driver system big change background. So that's the reason I say there is no universal answer for this angle. It always depends on your module combination and what tracker technologies you are using. So. But Trina have to do all these tests and calculation. So we make our final conclusion based to currently tracker structure. Yeah.
Okay, so that's definitely a topic that's not going to go away, especially with the dynamics involved. Meanwhile, just changing direction here, and this is. And I'm going to actually follow this up with a question to Fred, because the two are totally relevant here together. So meanwhile, in your calculations, in your presentation, did you actually assume larger wire size for the 455 watt peak Vertex module to actually accommodate the higher current levels that were going to happen?
So in our analysis, we kept the wire size the same. And the thought behind that is it comes down to project specifics of how long your DC and AC wires are for specific projects. And there are trade-offs between the wire sizing and the actual current that is being run through them. So if you increase the wire size, those larger wires are going to be more expensive, but you're going to have less power loss, voltage drop across them. And if you have, on the other hand, you might save some cost by maintaining the wire size, but then you're going to have a lot higher voltage drop across that, and that will translate to energy loss. So it's a matter of balancing the direct cost of the wires compared with the loss of energy and the cost of what that is in the specific project.
Okay, yeah, thank you. I got that. So Fred, relevant to bifacial modules, could would technically people are asking about higher mismatch losses. So what's the difference between central and string inverter solutions when you're actually going to use bifacial modules?
Okay. Surely bifacial module will cause a little bit higher mismatch loss because of rear side. In fact, mismatch loss is a kind of a cask effect. Mismatch loss consists of two parts. One is current mismatch within the string. The other is voltage mismatch between different strings. And furthermore, more than 90% of the total mismatch is from current mismatch. But unfortunately, whatever kind of inverter you choose, you can never solve the current mismatch loss. So it means that there's very tiny difference between central inverter and string inverter for the mismatch loss issue, even though we use bifacial module. Mark.
Got it. Okay, that's helpful. Moving back to the actual trackers here, Kevin. This relates to tracker lengths. I know you covered this aspect in your presentation, but the question here is, is there a limit to the tracker structure length, and what's the compatibility of the tracker with the Vertex modules, especially the larger 550 watt peak one that will be due out soon enough?
Yeah, I think for the trackers limitation for the length, it also depends. So for it's 1P or it's 2P, and how what module you are installing. So all these you need to do the just I introduced in my presentation. You always need to do the wind tenor test to combine the module and the one module's layout and your every structure design together to do the to evaluate the trackers the height and the length limitation. Just take our Vanguard product 2P 550 product for example. So we use the wind tenor test to increase our tracker length from previous around 45 meters to nearly 70 meters. So we spent nearly, I think, half a year to do the test again and again to ensure when we increase the length and still keeps high reliability for the whole system. So that's a whole process. So I don't think that there is a limitation, but I agree. If we decide a height or the length for the trackers, there is a lot of test and calculation and design work needed to do. Yeah, Mike.
Okay, great. I think this leads into as well several other questions, again with the design changes going on. But if this one, I think for Minhwa, how might the sort of uncertainty in reliability of, we're talking about these design changes, how does this impact the operational system costs from your analysis?
Yeah, so in our analysis, we did assume that the OPEX is pretty much the same across the three cases that we compared. But in reality, there are some considerations in the reliability when you have new technology or changes in a product. But this is true for any kind of a product change. So whenever there's new changes to a product, there's always uncertainty about whether those changes will introduce new modes of failure. And at DNV GL, this is one of the things that we focus on very much so in all aspects of looking at equipment. And the main ways that we mitigate or look at that reliability risk is some way to say that the product was tested. So, how do we, in lack of a better word, test the heck out of this product? And the more accelerated life testing or field data that is available, the more confidence that can be had around the long-term reliability and performance of these modules. And the more that we can gather field data and test these modules or product or tracker changes, whether that's in the field or in the lab, by stressing under various environmental stress, wind, field exposure. These are the type of things that can, if they are quantified in some sort of way through the data, through statistics, that's one way in which we can then take that and place it into future financial models, or be able to quantify that into perhaps a stress case in the financial model to account for, what is the downside if failures do occur, or maybe the strategy or the mitigation is that there's additional contingency around additional O&M costs. And I think ultimately it kind of comes down to also being able to correlate that field data and that accelerated life testing into numbers that we can practically use into these into the O&M costs. And so it's certainly going to be an ongoing question and back and forth between conversations with our customers and also with the data that we see from operation and also from testing.
Got it. Got that. Thank you, Minhwa. Maybe squeeze in one more question or so, looking at the time. Kevin, you talked about the new sort of bearing design, but lots of people are just really asking here, what's the real advantage of this? Does this have a higher cost associated with it? And I guess that's in connection with like the slewing drive, the linear actuators. Looking at the time, I said we haven't got much, but maybe just can briefly comment on that, and then I'll just ask one more question. Thank you.
Okay. I think regarding the bearing, I think first we need to understand for the bearing, although it's very small components, but from Trina's view, bearing is very critical components in the whole system, although it's small. So because every rigid structure is connected by the bearing, and we are using the bearing to driving the whole system to do the rotation function. So bearing is very critical components here, combined with linear actuator or slew driver. So this is first, and the second is for Trina's bearing is quite special. Just now I have introduced in my presentation. So Trina's bearing is like a spherical bearing system. So this is a totally patent and unique design. So use this unique design. This bearing can rotate all around all angles by 30% for different angles. So with this flexible adjustable function, so you can be totally achieve the maximum tolerant to accept the tolerance during your installation and the whole life cycle, the deformation and tolerance because of the land and also the installation. When this deformation happens with the bearings, the flexibility, you can release the stress. So the stress release during the installation and the whole life cycle is very important for the reliability and stability for the whole system. So I think the bearing is especially playing a very critical role in the whole system. So that's my opinion, Mark. Thanks.
Well, thank you, Kevin. Well, thank you, everybody, actually, because we've kind of gone a little bit over, but some really good questions, and we've only just touched on a few of the ones that were coming through. So once again, thank you to our attendees today for this Trina Solar webinar. Thank you, the presenters. You did a great job. And hopefully we'll see you again soon at another PV Tech TechTalk webinar. Well, that's it for today. Thank you very much for turning up. Bye-bye.